Vanakkam Makkale, nice to see you on another episode of Konjam Mokka with Science. Now we all know that there are things all around us, everywhere. But did you know there is something opposite to things? Kinda like unthings, if that makes any sense? Well, if not, don't worry. We'll decipher this weird phenomenon together. Well, to start off, this thing called unthing is scientifically called antimatter. It is the opposite of normal matter. To be more precise, the subatomic particles of antimatter have properties opposite to those of normal matter. The electrical charge of those particles is reversed. When matter and antimatter meet, both disappear in a flash of energy. Antimatter was created along with matter after the Big Bang, but antimatter is rare in today's universe, and scientists aren't sure why. To better understand antimatter, one needs to know more about matter. Matter is made up of atoms, which are the basic units of chemical elements such as hydrogen, helium, or oxygen. The universe of an atom is complex, as it is full of exotic particles with properties of spin and flavor that physicists are only just beginning to understand. From a simple perspective, however, atoms have particles that are known as electrons, protons, and neutrons inside of them. Each element has a certain number of protons in each atom. Hydrogen has 1 proton, helium has 2 protons, and so on. Okay, so now that we know thoroughly what matter is, let's dive deeper into antimatter. In the heart of an atom, called the nucleus, are protons, which have a positive electrical charge, and neutrons, which have a neutral charge or a charge of 0. Electrons, which generally have a negative charge, occupy orbits around the nucleus. The orbits can change depending on how much energy electrons have, or if you will, how excited the electrons are. In the case of antimatter, the electrical charge is reversed relative to matter, according to NASA. Anti-electrons, called positrons, behave like electrons but have a positive charge. Antiprotons, as the name implies, are protons with a negative charge. NASA stated that these antimatter particles, which are called antiparticles, have been generated and studied at huge particle accelerators such as the Large Hadron Collider, operated by CERN, the European Organization for Nuclear Research. NASA said, and I quote, "Antimatter is not anti-gravity, although it has not been experimentally confirmed. Existing theory predicts that antimatter behaves the same to gravity as does normal matter." Well, now that you know a little bit about antimatter, you may be thinking to yourself, okay, Shruti, if this thing, or unthing in this case, that I've never seen before really exists, where is it? Okay, before you guys come at me, let me explain. Antimatter particles are created in ultra-high-speed collisions. In the first moments after the Big Bang, only energy existed. As the universe cooled and expanded, particles of matter and antimatter were produced in equal amounts. Okay, but if both matter and antimatter were created equally, then why does matter come to dominate? Well, that's a question that scientists have yet to discover. One theory, though, suggests that more normal matter was created than antimatter in the very beginning, so that even after mutual annihilation, there was enough normal matter left to form stars, galaxies, and us. Wait, Shruti. Didn't you mention that when particles meet, they create energy? Can't we use that power to create other stuff? You're right, we sure can, but here's the catch. Like I mentioned earlier, when antimatter particles interact with matter particles, they annihilate each other and produce energy. This has led engineers to speculate that antimatter-powered spacecraft might be an efficient way to explore the universe. NASA cautions that there's a huge catch with this idea. It takes about $100 billion to create a milligram of antimatter. While research can go on with a lot less antimatter, this is a minimum that would be needed for application. To be commercially viable, this price would have to drop by about a factor of 10,000, the agency wrote. Power generation creates another headache. It costs far more energy to create antimatter than the energy one could get back from an antimatter reaction. But that hasn't stopped NASA and other groups from working to improve the technology to make antimatter spacecraft possible. In 2012, research showed that it's possible that antimatter could be used about 40 to 60 years in the future. Well, until that time comes, I'm okay just taking the train. Hope this episode on antimatter helped you look at matter a bit more in depth and opened your eyes to a whole new spectrum. See you on next week's episode covering more interesting topics just like this. Until then, stay safe and stay curious.